All right. Hi, everybody. Let's get started here. Shh. Calm down. All right. So I want to talk about some end of the year stuff here to start. So if you, I offer the option of taking a doubled high test score, doing a test retake. So I'd like to get that information from you by this week, Friday. So this, if you click on this link, it'll take you to a Google Doc that you fill out, and that'll, we can even look at it. Why not? Right, it's put your name in, record what hour, what you want it to do. You know, if you're doing the retake, you say what test you're planning on doing. If you're doing the retake, when are you planning on doing it? And if you're planning on a study hall, like who's your study hall teacher and what hour is it? Right, easy form. Again, we need that done by Friday. So I'm looking at this in the content library. This is the same thing as in the My Notre Dame also, though, if you look at the announcements or whatever. The drops, so I'm going to drop a homework grade and a quiz grade. Both of those have already happened. I had to do that when the seniors were getting ready for their exams. But don't worry, every time a new grade comes in, like that stuff all gets automatically updated by the computer. So I promise you that's happening. You can't see what's being dropped, but I promise you the computer's found the lowest thing and done it for you. The exam is going to cover chapter 7 through 11, 14 and 15, 70 total points, 10 points per chapter, so 2 to 3 questions per chapter. There'll be variations of old test questions. You can make an 8.5 by 11. That's just like your standard size sheet of paper for notes for the exam. You can put anything on there you want. You can write on both sides of that sheet of paper. The notes have to be handwritten, and those are due to me by the end of the day on Wednesday the 31st. That's the last day before exams start. Earlier is fine. And if you have any missing or late stuff, the last day for that is end of school on that Wednesday the 31st. Cool with that? Okay. Also attached in here is the equation sheet that I'm going to provide for you for the final exam, so you don't waste your time trying to write down any of this stuff on your own note sheet. Cool. Since the test questions are just going to be variations of old test questions, am I going to give you a review? No, because what should you do? Work on the old tests, right? You're just going to redo the old tests and stuff. Everybody cool? Seem fair enough? We've been working in chapter 15 here recently. With my arm getting broken, we missed the class period. It doesn't look like we're going to be able to do the test for chapter 15 without like really rushing and kind of putting an undue burden on you guys to have a 7th test that I don't really feel like is going to tell me anything more than the previous 6 are going to tell me. So the chapter 15 stuff will be exam only. Nolan?
Just wondering, because of the form, when do you think you'll have the last test graded?
I have them graded if you've taken it on time. If you're late, I'm still kind of getting those together. But I should have them in here before Friday, certainly. If not this afternoon, then tomorrow morning.
Thank you.
Yeah, absolutely. Fair question. So the chapter 15 stuff is going to be exam only, right? We'll still have some homeworks from chapter 15. We're going to finish chapter 15. I reserve the right for a homework quiz on chapter 15, but no test. Fair enough? Okay. Alrighty. Everybody feel pretty good about the end of the semester kind of stuff going on? Where we're at, what we're still going to do, what we still have to do, what you're still responsible for? I think that felt pretty good, right? Okay. Do you guys want to start with homework questions? I think last time we asked you to do up through 82. Has anybody got any questions from the homework set? Nolan? Ava, we'll go to you next. Oh, sure, go ahead. Like a blank version? We can probably do that. Remind me next class, and I can do that. Or if there's time at the end, remind me again, and I can see what I got. Yeah, CJ? Nolan's, and then I'll come to you. So Nolan, I had called on first. I'm happy to do it.
I was just wondering if you could do 16. Because I thought I knew how to do it, but then I tried drafting it. It just wouldn't work.
Oh, sure. I don't know that there's anything I would do for graphing on this one. So let's pop that question in there. So it says the population P in millions of people of New York State T years after 1800 can be modeled by the equation P of T equals yada yada yada. What is the population of New York in 1850? So what value of T is 1850 going to correspond to?
Years after.
So the value for T is 50, right? So I'm just plugging 50 into the function. Probably the way that I would do that is I'm just going to type it into the y equals. Oops, not alpha. Second. There it is. 0, 3, 5, 0, 5, x. Oh, dang it. Try it again. Apparently I didn't press down. I think I did. 1 plus 57.993 negative 0.35005x. Okay, there I got it. So I'm just going to do, since I typed that into y3, I'll do vars, y vars function, y3 of 50. So I get this, but remember P of T is in millions of people, so that's like 1.79 million people. Or you could write it as 1,794,000. Yeah, you get the idea, right? Part B says, what will the population be in 2010? So same idea, the T there should be 210 since it's 210 years after 1800. So I do that, I get 19.16 million. And then the last question asks for the maximum sustainable population. So I should recognize that the function P of T here is a logistic function because of the form that it's written. So I remember a logistic function has two asymptotes. One of them is at y equals 0, and the other is y equals c, where c is just the numerator of the logistic function. That numerator is going to be the upper bound. So that's like the maximum sustainable population is just 19.875. And I didn't use my calculator at all to get that. I just used what I knew about logistic functions. Does that feel okay?
Yeah.
Yes, sir.
So if it said like when we reach a certain population, would you then just graph it and then graph it?
Find the intersection. Yeah, the thing you'd have to be careful about here is if it was like when is the population 15 million, you'd have to type y equals 15, right? Because the p is in millions of people. So 15 million is just 15. So you type that in as like your y2 and then find the intersection. If you typed in 15 million, it's never going to get there because the asymptote's at 1980 or 0.875. So go ahead.
This one's quick. It's just for number 12, I think, or number 11. It said, what year will the population reach 800,000? And so it starts in 1990, and I got 15.44 years after.
Okay.
So the answer would be 2006 or 2005.
Well, because it says in what year, I would say between 2005 and 2006.
Oh.
So it's not asking when is the first year the population is at least 800,000. If that was the case, you'd answer 2006.
Yeah.
This, I think it's leaving you a little bit more wiggle room for how you want to phrase that answer.
Okay.
Does that feel good?
Yeah.
Okay. CJ, you had
34.
34. Okay. All right. Here it says the number of grams of carbon-14 denotes C present in a certain substance, T yees. I'm guessing that is supposed to be years. I don't know what kind of unit a yees is. Or maybe that's a yaz. I don't know. Is given by the function C of T equals yada, yada, yada. Use the equation to estimate the half-life of carbon-14. So the half-life is the amount of time it takes for half of the initial sample to go away, right? So I can see by looking at this, the initial amount is $20, right? Because if I put 0 in for T, I just get 20. So the half-life is going to be when it goes down to 10. So it's the amount of time it takes to go from 20 to 10. Okay? So I'm going to go ahead and set a window now. Anybody know what scientists use carbon-14 for?
Oh, like carbon dating.
Carbon dating, yeah. So we can use the amount of carbon-14 left in an organic sample to tell how old that sample is. So carbon dating can tell things are like thousands and thousands of years old, right? So what that's telling me is the half-life of carbon-14 is probably a pretty big number. So I don't know, I'm going to put like 10,000 years because I think they use it to even do prehistoric stuff. So I'm guessing it's a pretty long time. The Y min, well, it's a decay, so that can just be 0. The Y max, I'll just set at 20 because that's how much I had to start with. And that ought to give me a pretty decent picture there. So there's my decay curve. There's my line for 10. So second trace, intersect command, enter, enter, enter. So 5,700 is about my half-life. So the trick there is just like recognizing like, oh, the T is going to be really big. You know, not just like 100 or even 1,000. It's going to be like real big to where you can like tell how old dinosaurs are and crap like that. Elena?
Is there a way that you could solve this, like just using the equation? Or
Sure, yeah, you could absolutely write C of T as 10 and then use like divide by 20, do the natural log, and then divide by the negative 0.01216. And that would certainly work. Should get the same 5,700. So just to show you, natural log of 10 divided by 20 divided by, oops, I had to close that. I swear I did. Negative 0.0001216. There's that same 5,700. Does that feel good, Lena? Okay. CJ, you happy? Yeah, no problem. Anybody else on questions from homeworks? Okie dokie. We're going to go and pick up where we left off last time. So we were working inside of 15.3. We had just talked about expanding logarithms, and now we're going to talk about condensing. So condensing, we're going to do the opposite order on our properties as we did for expanding. Expanding, we go from quotient to product to power. When we're condensing, we're going to go the opposite order. We're going to go power to product to quotient. So let's go and look at a couple of examples here. Oh, darn it. So the first one, again, the directions say to use condensing. So the first thing we want to look for is a power property. Since we're going in the reverse order, to use the power property, instead of looking for an exponent inside the logarithm, I look for a coefficient in front of the logarithm. Do we see any power properties here? Yes, good. How many? 2. Because we see the 3 and the 2, right? So we can apply the power property for each of those. Now, common question here is, Mr. Kulik, could I use, instead of you did a power of 2, could I have done power of -2? What do you think? Sure, that's going to be fine. What alteration would you have to make, though? Yeah, it would have to be, you'd have to think about it as plus a -2. So you should have a plus log 5x squared if you wanted to go that route. I would not, but there's nothing wrong with doing it that way. Next thing up is we're looking for a product property. Instead of looking for multiplication inside the logarithm, because we're going in the reverse direction, we're going to look at for addition between two logarithms. Do we see any product properties here?
Yeah.
Yes, how many? 1, right? Because there's one addition symbol. Yeah, I know you meant 1. So it's in between those two guys, so we can write that as log 4 of xy cubed minus log 5 of x squared. Okay. The last thing we're going to look for is a quotient property. What do we look for to indicate a quotient property when we're condensing? For a minus. But a quotient property does not actually apply here. Why not?
Because they don't have the same subscript.
Yeah, the bases on the logarithms are different, right? To use either the quotient or product property, the bases for the logarithms need to be the same. So it was fine when we did the product property because both the logarithms were base 4. Here, because one base is 4 and the other is base 5, we can't actually apply the quotient property. This is as good as you can do. It's just like a sneaky question where Mr. Kulik's tried to fool you. Okay, let's look at the next one. Okay, first step would be to look for power properties. Good. How many power properties do we see? 3. Okay, I agree. So we'll just take those those coefficients and change them into exponents. Now the one place we have to be a little bit careful is that middle logarithm. How do I need to write that when I move that exponent in there? So yeah, you'd put a set of parentheses around the a and the b, and then put the cubed outside. Or you could write it as a to the third, b to the third, and put the exponent on each of them. Either would be okay. We'll eventually end up with a to the third, b to the third. But either way of writing it is okay. Okay. Next step is product properties. Do we see any of those? Yes. How many? 1. Great, because you see the plus sign. What 2 logarithms are involved? What? No, I mean, like we have 3 logarithms written in the problem. Which 2 are being used by the product property? That's actually incorrect. The first one and the last one. Why not the middle one? Because it's negative. Yeah, the product property exists between 2 positive logarithms. And I know I can add things in any order, so I could easily rewrite this so that the 2 positive things are right next to each other with a plus sign in between them, right? So that's the sneaky part where Mr. Kulik's trying to trick you here by writing these in a funny order. Almost gotcha, didn't I? And then the last step would be to do my quotient property. And notice here that these are both the same base logarithm. So this time it would be okay to do that. What do you notice about the fraction inside the logarithm? Yeah, we can reduce it. So let's go ahead and do that. Everybody happy with what we did? Certainly. All right. That looks good for 15.3. In 15.4, we're going to be solving exponential and logarithmic equations. So we're just going to do some examples here of that and talk about the techniques we can use. So let's take a look at this one. I have 14 times 1/3 to the x minus 1 equals 26. So this is an exponential equation, right? Because the x is in the exponent. To solve any exponential equation, the first order of business for me is to try to get the exponential piece by itself. So I'm going to start by dividing by 14. So 126 divided by 14 is 9. Now to solve this, I could approach this in 2 different ways. One way I could do this is I could try to rewrite the 1/3 and the 9 so that they have the same exponent base. If I wanted to do that, what would the obvious choice be?
Change to 1/3 to -1/2.
Yeah, or you could use both of them to 3, right? Either would be okay. I'm going to go both of them to 3. I think that's a little bit more natural. But what you said, Nolan, would be okay. So I could do that, right? And I know the exponent of an exponent is multiplication. So I could say that. And since the two things are equal and the bases to the exponential are equal, that tells me the exponents must be equal. So I subtract 1 and divide by -1, I get equal to -1. Everybody's okay with how I did that? Alternatively, I could also accomplish the same thing by trying to cancel the exponent base of 1/3. What would I use to cancel the exponent base of 1/3? Log, great. What base for the logarithm would be the best one to use? 1/3. I'd want the base of the logarithm to match the base of my exponential. Now, just to be clear, this idea of using a logarithm works whether the bases match or not. But if the bases don't match, it's a lot messier. So I recommend, like, since you have your choice of any log, why not make it easy on yourself? And if I type log 1/3 of 9 into my calculator, I get 2. I'm sorry, -2. And then if I just add the 1 over, I get -1. You see, we get the same thing either way, right? Of these two methods, which one do you think Mr. Kulik prefers? Huh? Well, I don't care which one you do, but I think one of them is a better option than the other.
The one on the right.
The one on the right. Why?
Short answer.
Well, here's the issue. What if this number was like 8? How would you do the option on the left? You'd have to use a logarithm, right? Which in turn, it's just the same thing that you're doing on the right. So my opinion is just do everything using a logarithm, because whether it's easy to write the thing with a base, the same base or not, I know I can always do that. Now, that's not to say I wouldn't, if there's a particularly nice shortcut staring me in the face, take that shortcut and do like that option on the left, particularly if it meant I didn't have to get my calculator out. Would I still do that? Sure. But like, if you ask me which method is best, I'm going to pick the one where I can do it the exact same way every single time. You know what I mean? I don't have to like make any concessions or like, oh, that turns into a much weirder problem. They're all kind of the same. All right. Once again, what should I do first? Divide by 12. I notice that 27 divided by 12 reduces. They both contain a factor of 3. And you might notice, hey, pretty easy to write 9 over 4 and 3 over 2 so that they have the same base, because 9 over 4 is just 3 over 2 squared. That's supposed to be a 5, not a 7, Einstein. I don't know why it turned into a 7. Maybe it was just bad penmanship. Who the heck knows? So I can do that, right? Or what else could I have done?
Log.
Which log?
Yeah.
Yeah, log base 3/2. And again, log base cancels exponent base. Log base 3 over 2 of 9/4. I could type in my calculator, but I just did it a second ago. So like, I'm not going to bother typing into the calculator now, but there you go. NBD, right? Pretty easy so far. Everybody feel okay? Let's take a look at this next situation, which is decidedly different. This would be like the hardest type of exponential equation that I'd be asking you to solve. So let's say we have 3 to the x plus 3 to the negative x all over 4 equal to 2. What's decidedly different about this problem than the previous ones? There's a denominator, sure, but like...
there's two things that have x.
Yeah, your variable's in two different locations, right? Okay. So first order of business for me would be to... Well, I'd multiply by 4. I'd like get rid of the fraction here. That's not helping anybody, right? So let's do that. Okay. Now, again, I want to try to get this x in one place. So I would try to rewrite this without the negative exponent. How do I rewrite that with no negative exponent? Or what can I do to get rid of the negative exponent even?
Divide by 3 to the x.
Divide by 3 to the x? Well, I would say you could multiply by 3 to the x. That would be okay. So when I multiply 3 to the x times 3 to the x, what do we get?
X squared.
Nope.
5 to the x.
You could write it as 9 to the x. What else could you write it as?
3 to the 2x.
3 to the 2x. Or what else could you write it as?
47 to 1/2 x.
I'm going to write it as 3 to the x squared. That's the way I'm going to choose to write it. You could write it as 9 to the x, where you multiply the basis and keep the exponent the same. That would be okay. You could write it as 3 to the 2x, where you keep the bases the same, but add the exponents. Or you could just write it in the naive way that I've done it here, just like 3 to the x times 3 to the x. Well, that's 3 to the x squared. And you'll see why I've chosen to write it that way in a moment. What do I get when I do 3 to the x times 3 to the negative x? Nope.
Oh, yeah.
Because I get 3 to the 0, which is just 1. Yeah. And what do I get when I do 8 times 3 to the x?
20.
No, not 24 to the x.
Keep it the same.
Keep it the same, right? The bases of the exponentials are different. The exponents are different. So there's nothing you can do to combine those things. Is everybody okay with what we've done? The reasoning as to why we've chosen to do things the way we have? Take a look at this now. What does this kind of look like now? Should start to look something familiar. It does look like a quadratic, right? We have something squared, something to the first, and a constant. Everybody good with that? So let's just pretend that it is quadratic. So I moved it all onto one side and replaced the 3 to the x's with y's. Oops. It's supposed to be all y's. There we go. Everybody's happy? Okay, so we have a quadratic equation, right? How do I solve one of those? Could factor, okay. What multiplies to give me 1 and adds to give me negative 8?
Negative 8. Or negative 7. Negative
multiplies to
1,
give me
-8.
1, and adds to give me -8. There you go. So if I can't factor it, what should I do? Quadratic formula. There you go. It was a trick question. Everybody always says, oh, factor it. And then it's like, oh, okay, how do I factor this one? And it's like, oh, well, you can't. It happens every year. That's the first answer because it's usually the right answer, you know. So apply the quadratic formula. Negative of -8 is just +8. -8 squared is 64, minus 4 times 1 times 1 is 60. So the square root of 60 reduces down to 2 root 15. And if I reduce that down, I have 4 plus or minus square root 15. Is everybody okay with what we did there, simplifying that? Okay. What variable have we solved for? Y. What variable are we supposed to be solving for?
S.
X. So let's fix that. So we'll just put the 3 to the x back. And because of the plus or minus, I'm now going to have to write this as 2 separate equations. So I have 3 to the x equals 4 plus root 15 and 3 to the x equals 4 minus root 15. How do I solve those equations for x? No. 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 What? Log base 3 of both sides. There you go. Right? We got to cancel the exponent base of 3. So now it's just calculator time from here, right? So to get the log where I can type in a base of my choosing, I press the math button, scroll all the way down to the bottom until I see the log base option. That allows me to type in whatever log base I want. So there's my log base 3. Then 4 plus square root 15 gives me 1.88-ish. And then if I just update that to be a minus 15, gives me a negative 1.88-ish. How's that feel? So far, so good? That's kind of the worst case scenario for an exponential, right? Where you end up having that quadratic kind of shoved in there also. But that was kind of the moral of the story in Algebra 2, wasn't it? Like every solving problem eventually turned into a solving quadratic, or at least in the worst case scenario, it turned into that. It's like, oh, this is just happens over and over again all semester long, huh? All right, let's take a look at some logarithmic examples. So for a logarithmic equation, the same kind of idea holds. I want to start by just getting the logarithm part by itself. So in this case, I would need to
What about the
divide by 3. And now, how do I get rid of the logarithm on there?
do an exponent?
Do an exponent base of 10. Yeah. Why did you pick 10?
Because that's what the log is.
Right. If there's no subscript written next to the log, we recognize that as the common log, who we know the base is 10. Now, when I write this down, I'm going to write a comically large exponent base, just so I don't confuse myself later on and think that I multiplied by 10 when really I'm using an exponent base of 10. It's really important that you write 10 squared and not 20. Everybody's cool? All right, so I have 10 squared equal, or x squared equals 10 squared, so what's x equal? And now, yeah, plus or minus, because you have to do the square root of both sides. But we're not done. The domain of a logarithm is not all real numbers, right? The domain of the polynomial x squared equals whatever that we just solved is all real numbers. What that means is that we may have encountered an extraneous solution. What we need to do is we need to check our answer by plugging it back into the x for the original. And we need to make sure that we do not get a non-positive inside of the logarithm. So if I plug 10 in for x, I get the log of 100, right? That's fine, because you have a non-negative or non-positive. I'm sorry, you have a positive number inside the logarithm. If I plug negative x squared in for x, I get log of 100. That's still fine because I have the log of a positive. I should have two solutions to this, 10 and negative 10. Everybody feel okie dokie with this? So far, so good? Let's do the tricky example now. So this is like the most difficult version of a logarithmic equation that we might be asked to solve. So here we have the natural log of 3x minus 2 plus the natural log of x minus 1 equals 2 times the natural log of x. What do you notice that's different about this problem than the previous one? Okay, we have more than one logarithm, and
There's the inside of the x.
yeah, the x's are in more than one location as well, right? So what's going to be my first order of business? I got to get this down to a single logarithm. What does that mean that I should do first? Condense. Yeah, that's exactly right. So let's move everything onto the same side. I notice that I have a power property here. I notice that I have a product property here. And that I then have a quotient property there. Everybody so far so good? I've got this down to a single logarithm now. Great. What should I do next? I mean, you could do that. You don't need to do it yet. We're not even sure if we need to do it yet. So I would just hold off on foiling until I know I need to do it. But eventually in this problem, I mean, I know I need to do it, but you don't know if we need to do that yet. I want to cancel the logarithm next. We got the logarithm all into one place for the express purpose of trying to cancel that. How do I cancel that natural log? Exponent base e. So I have e as my exponent base on both sides. Okay. So left-hand side, we're left with 3x minus 2 times x minus 1 over x squared equals e to the 0 is 1. So what are we left with now? It's a rational equation, right? Like chapter 14. Okay, to solve this, what should we do?
X squared.
Let's clear the fractions, right? So multiply both sides by x squared would accomplish that. And now we recognize we have a quadratic equation, right? Okay, to solve this, we're going to have to now FOIL everything out. You had a feeling it was coming. Here it is. Got to move everything onto one side. And now to solve this, I can either factor, it is factorable, but what's the problem if I elect the factoring route? The leading coefficient isn't 1, so it's going to be like that longer factoring method that maybe I remember how to do, but I probably don't based on the chapter 14 test that I looked at. So what should I do if I don't feel confident in how to factor this? Quadratic formula. In general, if the leading coefficient isn't 1, I would just use the quadratic formula because I'm guaranteed to get an answer there. Not everything is factorable. So I would just do that every time. Negative of a negative is positive. Negative 5 squared is 25. Minus 4 times 2 times 2 is 25 minus 16, which is 9. The square root of 9 is 3. 5 plus 3 is 8, and then divide by 4 is 2. 5 minus 3 is 2. Divide by 4 is 1/2. So those are my values for x, but I'm not done yet. What do I still have to do? Check for extraneous solutions. Where do I have to go to do that? You have to go all the way back to here. If I plug 2 in for x, do I get any negatives or zeros?
No.
No, right? So 2 is good. If I plug 1/2 in for x, do I get any negatives or zeros? Sure I do.
Right.
3 times 1/2 is 1.5 minus 2. That's negative. Everybody agree? Do I care what happens after that?
No.
No, man. One of those is enough to say, that's extraneous. What do you guys say? You remember doing this last year? Little bits anyway. Jean-Paul? Certainly, sir. This feels like a decent spot to stop, if you ask me. Particularly since, where are we at? We're at 83 to 130. That's a good chunk of problems that you dumped on all at once here. We still have a little bit more to do in section 3-4. They're all application problems. We'll do those next time, as well as the start of 15.5 and maybe finish 15.5 the next week. That'll leave I think 3 class days for for you guys to just kind of get your wits about you and do your reviews. And if you have to do a retake in class, we can use one of those days to do that and all that jazz. But we're going to stop here for today. What is still possible? this chapter 15? Homework quiz. I would expect either next class or the following for that. Everybody's cool? All right. Questions for me? All righty, dudes. What do you got, like a half an hour left here or something like that? I would pull out your stuff and get crack-a-lacking on this 83 to 130. You know, we're right at the end of the year. It's going to get hectic. Don't slack off now, or you're going to dig yourself in a big, stressful hole. You know what I mean? Stay on top of it. Only got a couple weeks left. Not much school. Finish strong. Right? We've worked very, very hard. Don't flush it all down the tubes now because you're like a little bit tired. You can be tired in June. Still May.